right, let's check out numbers 2. So the classic given a table problem. And I know, again, you have numbers and you can have a calculator in front of you. So it says that grain is being added at time t equals 0, the silo is empty. The rate at which grain is being added is modeled by a differential function where g of t is in cubic feet per minute, and of course t is in minutes. And selected values are given in the table. Using the data in the table, approximate g prime of 3. Oh, such a classic problem. Guaranteed. I would bet my life there'd be one like this. So, and again, using correct units, interpret the meaning of. Okay, so g prime of 3. You're given g. You're asked to approximate the derivative. So to approximate the derivative, you're going to use the slope of a secant line. So g prime of 3 is going to be approximately equal to, you go to the ones around 3, so I'm going to look at these two, and I'm going to do g of 5 minus g of 1 over 5 minus 1. Now, you didn't necessarily have to write that. If you went straight to the 20.5, I just want to make sure that you understand what I'm doing. And then 5 minus 1, or of course, you could put 4, but you can leave it as 5 minus 1. So I would stop right there since you can. And that was worth 1 point, just getting that. Again, you have to show the difference quotient and get that answer. Now, but that's not all the question says. And you go, well, shouldn't I put units on that? If this part weren't there, then yes, you would definitely need units. But it says using correct units, so I'll have the units in this next part. It says using the correct units, interpret the meaning of g prime of 3 in the context of this problem. So remember, that's the nut. Noun, what it is, units, and specific time. So you have to have all three of those things. It doesn't really matter at what order. But what are you approximating? Remember, g of t is a rate in itself because it's cubic feet per minute. So remember, for units, if you're taking the derivative is take the units of this and divide by your time because that's the rate. I mean, think of the units of this. We're cubic feet per minute. And then divide by minutes. So the units are going to be this. Okay? So you can get that from there. So I would say something about, and I can look at this number, even if I don't get the actual number. Yes, you have a calculator if you want to get that pretty quickly, but I can tell that that's going to be a positive number. So I know that the rate is positive. So that means the grain is going to be being added at an increasing rate. So I'm just going to say at t equals 3 minutes, the rate, I'm using words from the problem, at which grain is being added is increasing. Again, how did I know it was increasing? Because I can look at this and know that it's positive. If it were negative, I would say decreasing at this particular, or you can say the word changing. So you can do that too. I like saying increasing or decreasing. At a rate of, now again, I don't even have to get that number. I'm just going to copy that again if you think it's faster to get that number. At a rate of that feet cubed per minute squared. So again, the points for that one, there were 2 points. There was 1 for getting this answer, and this is good enough. And then there was 1 for the explanation. And remember, the explanation has to have all of those parts. So if you didn't put at t equals 3 minutes, you would not get that point. If you did not have correct units, you would not get that point. So every piece of it has to be correct for you to get that. So that was letter A. Now let's see, why does this not erase? I swear I hate this thing. I literally hate this thing. I mean, really? This is how I have to do it? I know that is so super annoying. Beep, 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 beep. This is ridiculous. Come on, erase. Okay, now it is. Oh, you just have to be mad at it for a minute. Okay. Letter B. Write an integral expression that represents the total amount of grain added to the silo from t equals 0 to 8, and then use a right-Riemann sum to approximate that. So again, stop at the period and do what they say. And I like to label my stuff. So total amount of grain from t equals 0 to t equals 8 is equal to, what's the integral expression? That would be 0 to 8 of g of t, wouldn't it? Because that's the rate that it's being added. And so if I integrate cubic feet per minute, remember when you integrate, that's times minutes, so you would get cubic feet. So that's, okay, that's the volume that it's in there. That makes sense. The units make sense. Now use a right-Riemann sum with 4 subintervals indicated by the data in the table to approximate the integral. So this integral is going to be approximately, I should have 4 rectangles. A right-Riemann sum, I know I'm going to use the right 4 y values, but notice, y'all, you're doing rectangles. Width, height, width, height. Here are the 4 heights you're going to use. Now be careful on the widths. Did it say equal widths? No, it says 4 as deemed by the chart. So if you think about plotting this, 0, 1, 5, 6, and 8, your rectangles are coming up like this. And I don't look at my y values because I'm just totally drawing rectangles. So notice that the widths are going to be 1, 4, 1, and 2. Not that you have to draw by any means. I just did that so you understood. So here are going to be my widths. Here are my heights. Now just write it out. Obviously, I don't have to write 1, but I'm going to copy the numbers very carefully. 4 times 20.5. 1 times 18.3. And 2 times 22.7. Now I'm going to put units on there, which is what a lot of people forget, is that, remember, what are the units? The units are going to be feet cubed. Now, I can either put it down there or I could either put it up here, either one. I kind of ran out of space down at the bottom. But somewhere on there, I need to have units. Again, I would stop there. You don't have to get the actual number, and that just wastes time. So you don't necessarily have to do that. The points, you got 1 point for the integral expression, and then this was actually worth 2 points. One that you did a right-Riemann sum, like if you miscopied one number or something, but they could tell you were doing, like if you put, 20.6 or something unfortunate, you would get a point that, hey, I knew that they were doing a right-Riemann sum, and then 1 point for the answer. And so, again, I would just leave the answer like this because there's no chance of me making a careless mistake. So that is letter B. Gotta love those Riemann sums. Let's see if it's going to erase. Come on, baby. Oh, yeah. Now, part C says, the grain in the silo is spoiling. So you're adding some in, okay, at this time, and then it's spoiling, where W2 is measured in cubic feet per minute. So again, it's a rate. So, okay, first of all, it says it, but you can look at the units and tell that it's a rate. Using the result from part B, approximate the amount of unspoiled grain remaining in the silo at t equals 8 minutes. Okay, so think to yourself, what would be, okay, read it carefully, the amount of unspoiled. This is the amount that's spoiled. So your brain should think, well, I would have to figure out how much is in there, how much did we add in, and take out what part was spoiled. So the amount of unspoiled, this is part C, at t equals 8 is going to be what? I'm going to take the amount that's in there minus the amount that's spoiled, correct? Now, the amount that's in there was the answer that you got to part B. So here's the deal, and I know because they're like, okay, so I really should have gotten a number on part B. I wouldn't have, because I would get answer. I didn't know what the next question was. Yes, if I wanted to type that up, that didn't take me, you have a simple calculator, you'll have a graphing calculator in front of you. I would type that up for sure. And that answer was actually 160.8. So that's the amount that's in the silo at 8 minutes. And then you're going to take out the part that's being spoiled. Well, that's the integral from 0 to 8 of WT dt. And again, I don't, with this exam, it's so different because they said, you don't have to have a graphing calculator. And so I don't know if you'll actually have to get the answer. They would just probably say, write, the integral expression and not get the number. I will tell you what the number is, but I think with this 2020 exam, that number is kind of irrelevant because I don't think they're going to ask you to go that far. But you certainly would be asked to write a integral expression for sure and get you thinking about that application. All right, last part, letter D says, based on the model in part C, is the amount of unspoiled grain in the silo increasing or decreasing at t equals 6? Okay, so think about that. Okay, think about what that's saying. We talked about, we looked at 8, at t equals 8. Right at that moment, you take the amount that's in minus the amount that's spoiled. But the question is saying, it's talking about the rate, right? Because it says, is the amount of unspoiled grain increasing or decreasing? So you would have to think, okay, well, is the rate that I'm putting in grain faster, more than the rate that it's spoiling, or the other way around? Okay? Or in other words, I think this is an easier way to do it, is G of 6, okay, the rate that you're putting it in, minus, W of 6, is that number positive or negative? I mean, what is that? Because if the rate that you put it in and you take out the rate that it's spoiling, if that's a positive number, then the unspoiled grain is going to be increasing, right? However, if you're putting some in but it's spoiling faster, so the rate at which it's spoiling is a lot bigger, then this will be negative. So that's really the question. And again, you have a calculator. G of 6, I mean, literally, I'm to get that number, that would be 18.3. I literally read it off the chart, minus W of 6. Not that you have to even show these numbers. I mean, I probably wouldn't, but I would plug this in. And I'll be honest, I really actually didn't do that when I wrote my paper. So I don't know what that number is. Sorry about that. I don't have my calculator in front of me at the moment. But you could 18.3 minus, and then you just plug in W of 6 right there. This number I do have. You end up getting 2.237 if you do that subtraction, which is greater than 0. Again, make sure you write greater than 0. So since G of 6 minus W of 6 is greater than 0, the amount of unspoiled grain is increasing at t equals 6. Okay, again, is that the exact way you'd have to do it? No, if you compare G of 6 and W of 6 and this is greater than this, again, that's kind of the same thing. So there's more than one way to earn that point. But as far as the numbers, that was actually just worth 1 point. It's worth 2 points. 1 point for the explanation and 1 point, did you consider G of 6 minus W of 6? Or are you comparing G of 6 and W of 6? That would also get you the points. So there you go. There is number 2.